Hello, everybody. Hey, Spence. How are you, friend? Welcome. So those of you watching this on YouTube, you may have been seeing a thing saying day one, which, try as I might, I could not quite figure out how to get the stream key to pick up today's episode instead of yesterday's. This is not day one, this is day two. And yes, we are, well, I say we are, I'm doing most of the typing, and folks out there on the internet are piping up with occasional observations and suggestions and useful little pieces of pair programming. But yes, we're building an interpreter for the Rockstar esoteric programming language, which is my favorite pet project of all the things I ever did, because it is alternately creative and funny and silly, and it's an interesting and fun thing to work on. And so yeah, we're building a Rockstar interpreter in TypeScript, which is fun because TypeScript is a language that I know JavaScript very well, worked with JavaScript for lots and lots of years. TypeScript is unfamiliar to me, and what I'm doing with it is I'm figuring out various deficiencies in the existing Rockstar interpreter, which is built in JavaScript. It's a thing called Satriani, and I'm figuring out how to use TypeScript to replace some of the cruft that I don't like. Things like having strings all over the place that have special meanings because JavaScript has no types. And yesterday started from pretty much nothing, actually. Started from scratch and got as far as getting a simple TypeScript runtime up and running, getting the TypeScript compiler installed, getting a couple of pieces, downloaded and set up and running and stuff. And we got as far as this, which is a very rudimentary interpreter written in TypeScript that is running on, just give me a second, I'm just going to check a couple of details here. Yeah, that's alright, that's cool, that should be fine. I had some weird behavior going on with streaming keys and things a minute ago. And at one point I had two YouTube windows open, and one said I was live and the other one said I wasn't, and they were saying the same thing at the same time, side by side. So that's alright, this looks like it's working. We got some folks out there. Anyone actually watching this on YouTube right now? If you are, just give me a little message in the chat, or say hello, or something. I think it's working. And besides, the stream is kind of half the fun. But the other half the fun is messing around with technology and programming and making computer programs that do things. So, yes, what yesterday got as far as this kind of setup here, which is a interpreter. Yeah, it's working, Spence, but you're on Twitch. So you telling me it's working on Twitch doesn't help me at all with knowing whether it's working on YouTube. Unless you're using YouTube to view it and using Twitch for the chat, which I know some people have occasionally done. But all right, let's have a look at what we got. So yesterday we got as far as this is integers.peg. This is a parsing expression grammar for a very, very simple language which just does arithmetic. It does addition, multiplication, and brackets, and that's all that it understands. And the thing that was interesting yesterday is how can we use the kind of TypeScript language syntax and object-oriented JavaScript to create strongly typed syntax nodes. Hello, UK Vemsword. Welcome, whoever you might be. Good to see you. So, yeah, we're looking at so parsing expression grammar. What I wanted to do is, can you inject TypeScript into PEG, and then get the PEG to generate JavaScript, and then have a TypeScript interpreter that consumes the parser that can... It's all a little bit sort of gnarly and complicated. Now, what I think... what I was just going to kind of kick off today by doing was to try and map out a little bit what it is that we've actually got going on here, what it is that we're trying to build. So the inputs that I've got here, it's documentation, by the way. You don't get very many people doing that live on Twitch. But basically, the inputs, the things which are written by hand by a human being, are going to be the grammar.peg. So this is going to be our language grammar file. Let me whack that up a little bit so it's legible on the stream over there. So we've got that's the parsing expression grammar for the language. Oh, thank you. Yeah, the NDC London Art of Code Talk. Thank you very much. It's I'll get a lot of people dropping by who saw that and quite enjoyed it. And I quite enjoyed it too. It was a lot of fun putting all that together. So we've got the grammar.peg file. There's syntax.ts. This is the TypeScript language syntax. And then there is the interpreter.ts, which is the thing that actually runs it. Now, what I was going to just map out here is the transformations and relationships that happen on these objects to turn these into the things that we're actually going to be working with. So we've got grammar.peg here. And then grammar.peg, that is going to run through, give me my visit more shapes, Visio extras connectors, that's what I want. So actually, I'm just going to make it a little bit easier, I'm going to call that parser.peg. So that parser.peg, that's going to get run through the peg.js compiler. So this is the peg.js compiler generator, whatever you want to call it. And I'll whack up the size on that a little bit as well. So we run parser.peg through peg.js. That gives us parser.js. Yeah. Now, the parser peg file there, syntax.ts, this thing is going to run through the TypeScript compiler, TSC. And that is going to give us syntax.js, which is JavaScript. Now these ones here, I'm gonna make these a different color because these are the things which get written by hand. These are red. These are things that are going to be written by a human. So the peg.js generator is going to give us parser. That's syntax.js. Now syntax.js is then going to be dynamically imported into. So I'm going to move this lot over here because if we have a look at the source code over here. For hey Tsarnal, how you doing? Call me Arex. I shall call you Arex. Hello Arex, how you doing? Now JavaScript is lovely. JavaScript runs everywhere without having to install anything. That's what's beautiful about it. And the whole point about doing this the way that we're doing with. Not only did I love your NDC talk, I made all my students watch it before making them go play with Pete, Sonic Pi, and Rockstar. Oh, amazing! That's brilliant. It's oh, that's really cool to hear. I love the kind of, you know, reminding people that, because it's really easy, particularly when you work in software, to just get to a point where you're like, I hate it. It's all like, you know, building finance systems and bugs and, you know, Kanban boards and all that kind of stuff. I'm like, it can be like that, but there's all this amazing stuff as well that does not get nearly enough kind of attention anymore. So, yeah, anything in there, I've had a couple of other people going, yeah, you know, I showed this to my kids and they loved it, and now they're doing Sonic Pi. And of course, Sonic Pi was created by Sam Aaron as a teaching language to get kids. It's you know, there's this wonderful idea of it. It's easy to learn something if you care about what you're trying to accomplish with it. Certainly for me, and I know for a lot of other people, that's very, very true. And so Sam's idea was, well, kids don't care about spreadsheets, and they probably, you know, there's an age where kids don't care yet about web pages and games and all that kind of stuff. But, you know, music is one of the earliest things we develop as human beings, the ability to appreciate melody and rhythm and stuff. And none of them chose to play with Rockstar. Give them time. They'll come around. Maybe they're just the wrong generation. Maybe I need a version of Rockstar that's like more contemporary music, like electronic dance music star or something. But yeah, the thing I love about Sonic Pi is, you know, anyone who enjoys music, it's like, well, look, you type this and it makes music, and people go, ooh, you know. Excel sheets are important, very important. Anyway, so, yeah, this thing here, so we've got this require mechanism here. This is our peg file. So this file is a expression grammar. It's not JavaScript. But this has this little block of code at the top which imports the syntax.js so that these lines here can refer to it. So we've got an import code inclusion mechanism. K-pop star, I like that. Not that I would be remotely qualified or knowledgeable enough to make a programming language based on the Korean language, but I do know the Korean alphabet is quite cool. I've read some very interesting stuff about it. I'm interested in typography and alphabets and stuff like that. So anyway, so we got this require mechanism here. So the this thing here, no, don't replicate the whole diagram. Excel's brilliant. I use Excel all the time for all kinds of things. And often people are like, how did you do that? And it's like Excel. And they're like, you can do that in Excel? And you're like, yeah. And if you've not seen it, there's a fantastic talk. There's a lady called Felina. Felina Hermans is the professor of spreadsheets at the University of Delft. And she has a wonderful talk about Excel. Excel is a pure functional programming language with immutable data structures. You know, think about that for a second. Like Excel, you basically have a set of inputs, and the inputs are immutable. And all you can do is you can have functions that take immutable input and they return some output that can then be cascaded through into other functions. It's brilliant. It's just, it has its quirks, you know, like having to rename all of the genetic study base pairs and things and protein names because Excel interprets them as dates and breaks it, and eventually the world just gives up trying to get it right and goes, you're going to rename the science. But yeah, Excel is very cool. So we've got our syntax.js. This is getting required by the parser.peg. So that is over there. So that runs that. That outputs the parser.js. And then that's our parser.js. Hey Antonio, welcome. How are you? So we've now got, this was our harness. So this one here, we are importing the, that's harness TypeScript. So this one we need to import the syntax and we need to import the parser, and those are both import statements. So there's some slight weirdness going, yeah. So we've then got the interpreter.ts. This is the thing we're actually building. So this thing needs to import. Now the thing we're going to look at today is, can we floating point arithmetic. Hey, welcome to my JavaScript stream, where 0.1 plus 0.2. Do you know about this? The weird JavaScript numerical quirk that we get sometimes? If we bring up a browser window here and we go inspect and we bring up a JavaScript console. Let me dock this back into here. So there's a JS console, and if we go on here and we whack that up a little bit and we go clear that and we go 0.1 plus 0.2, there, it's 0.3, because JavaScript, where everything is an IEEE floating point number, whether you want it to be or not. It is, I'm in the UK, so 4:30 p.m. here, so you got a 1 hour head start on me over there in Norway. Yeah, I mean, you know, the whole, Sanel saying that the biggest frustration with spreadsheets is ultimately they're part of legacy issues that cannot be fixed. Yeah. Oh yeah, you declare Winamp there? Yeah, Winamp's here somewhere. There we go. Look at that. It really whips the llama's ass. I just discovered there's like a whole bunch of music I hadn't listened to for years because it's not on Spotify, and I don't have a CD player anymore. So I was using Winamp to do some live streaming stuff, and yeah, Winamp's awesome, and it still works brilliantly. Absolutely love it. So we had this mechanism here where syntax, that runs into that, that runs into that. Now, at the moment, we then have the JavaScript import mechanism. So our interpreter has got, that is imported into there. And then that is imported into there. Yeah, so that gets imported into there, that gets imported into there, but then we've got the TypeScript compiler. Let me crunch this up. So that can go over there, that can go over there. I love Visio. Talking about using Microsoft Office applications, this is Visio, and Visio is just wonderful for doing this kind of documentation and laying out diagrams and stuff. So then we've got syntax.ts, syntax.js, parser.peg, that's interpreter.js. So this thing is then going to give us interpreter.js. And then what we are going to do is we are going to take the JavaScript thing here and we're going to feed that back through. So this is going to be our input, which is program.rock. And that thing is going to run through the interpreter.js, and that's what's going to give us our output. So I can grab a bigger arrow for that one. There we go, drop in one of those. That's nice. There we go. Boom. Send to back. Okay. So this is, I think, the architecture that nobody ever taught them database design. Just looking at what we got going on in the chat, people talking about Excel and all that kind of stuff. Never ever never underestimate the ability of smart people to solve the problem they've got with the tool you've given them. And that's so true of Excel. You know, the level of ingenuity, and you're thinking, if we taught you to program, but then people who know how to program don't end up working as accountants. They end up working as programmers. So those are some weird semantics in here. Okay, I think this is the architecture that we are working with here. I'm just going to save this into my folder where I'm doing random bits of stuff. D projects, where were we yesterday? It's in throwaway, although it's not going to be throwaway. It's architecture.vsdx. I'm going to clean this lot up after the stream today. Anyway, so that's what we got. We write the syntax. The syntax gets TypeScript compiled into syntax.js. Syntax.js runs through the import mechanism, so the interpreter pulls that in. The parser.peg, we run through peg.js. That gives us this parser. That gets imported into the interpreter. The interpreter gets TypeScripted from TypeScript into JavaScript. We feed the program into the interpreter, and over here we get our actual program output. It comes out the other side. Everyone got that? Isn't that beautiful? Look at that. And that are all gonna be generated by the thing for us. Let's change the line color to black on the whole thing. So, right, sweet. So, now one of the questions that I wanted to ask after yesterday's thing is this thing is harness.ts. This is built in TypeScript. Now we've got integers.js. Now that thing, I'm going to rename this to make this a little bit clearer, because I'm going to call this integers.peg is going to be parser.peg, because this is our parser grammar definition. And then if I fire up a Windows terminal here, have a look at what we got at the CD projects, throw away CD TypeScript hacks. You can tell this is still early prototyping stage because it's in a folder called throwaway and it's not committed to GitHub yet. But if I do peg.js parser.peg, yeah, actually, I'm just going to do a git init in this, and then I'm going to do git add. I need a git ignore for. There we go, git add dot, just in case, git commit -m, about to start renaming things. Just in case I accidentally zig when I should have zagged. So, we've got our parser.peg. If we run that through the peg.js thing, that gives us parser.js, which is our JavaScript parser. Now in our syntax.ts, this is our syntax TypeScript. We're going to be hacking around with that. We run that through the TypeScript compiler. That gives us syntax.js, which is this thing, which is generated by TypeScript. Then we import, so that syntax.js, that gets pulled in here by this line. That's the require. I wonder, because we've got require and import syntax going on here at the moment, which probably isn't going to be a deal breaker yet, but it's not as clean as it could be. I'm going to delete that and that because we're not working with those anymore. Those can both go. Yeah, move those to the recycle bin. Integers.js can go because that's been replaced with parser.js, and now our harness, that needs to be parser.js. Now my question is, if I do that, an import path cannot end with a TS extension. Why not? So I want to have a look at TypeScript import other TypeScript. Module export class, that's fine. You can use import statements just like that. All right, let's try. Now this is going to be interesting because I don't know what that's going to pick up. Is that going to pick up the TS file or the JS file? Since TypeScript, you can use simple import file or the wildcard. All right, let's see what this gives us. So over here, that should be all right. Now, what we're actually trying to do here is run harness.ts. So TSC harness, TSC TypeScript compiler, harness.ts. And if that works, we want node harness.js. And that should run. Okay, that's good. That's working. Now what I'm interested in is this syntax thing here. Is that picking up? If I delete syntax.js, which doesn't matter because I can easily get it back and run that again. What do I get now? Okay, good. That works. So this thing here is picking up syntax.ts, not syntax.js, which I don't know if that makes any difference yet. Any reason you use code instead of community, for instance? I'm not sure what's the context of the question. I'm sorry. Did I miss a message in the chat? Yeah, I'm not sure. You said any reason I use code instead of community. I'm not sure what community refers to in this context. Oh, I'm using VS Code now. Yeah. What is community? Oh, you mean for doing Visual Studio programming? Code is smaller and faster and lighter. I use Visual Studio full-blown for heavy lifting, like .NET and ASP.NET Core and all that kind of stuff. But when I'm doing live streaming, I optimize for fun, and Visual Studio Code is fun. And also I got this synthwave neon color scheme going on here that I haven't worked out how to migrate into full-blown Visual Studio yet. And well, that's a big deal. So yeah, no, I tend to, for poking around stuff like this, I like VS Code because it's lightweight and it's fast and it doesn't do very much for you. So when I'm doing full-blown Visual Studio, there's constantly stuff going on with, I have ReSharper and all these kinds of things. I got WebStorm on here as well somewhere, which I know does good stuff with TypeScript. But at the moment, we're playing. And the thing about playing is that you use tools that don't do a whole lot so that you learn as much as you can in the process. You don't want to automate the thing until you understand it. Otherwise, you end up automating something that wasn't necessary in the first place. And then you're like, well, we've automated it. Now we might as well keep it. We got plenty of pink. Look at that, nice hot pink and neon. And anyway, so we got to this stage. Now then, that's all pretty good. Now I want to chop out a bunch of these console.log expressions, which are not necessary for what we are working on here. Because what I want to look at today is, so we got that our result equals that. So I'm just going to console.log that thing in there, that chunk of stuff there, and run that. It should just give me 26. I need to evaluate that thing there. So this is my abstract syntax tree. let abstract syntax tree equal that, and console.log evaluate abstract syntax tree. So I can do a console.log here, and then I'll just do a console.log. Nice. That should delineate what we got and give us some kind of context what's going on with it. And I got a bunch of stuff in here that is there. That console.log needs to come out. But what we've got is there we go. So we've fed in a very simple expression. We fed in this thing here, 1 plus 2 plus 3 plus 4 times 5. It's run that through the parser. We've got an AST out of it. The AST looks like this. It's an addition node with a left-hand side and a right-hand side. That's all fine. And just to prove this actually works, we can do a plus 6 times plus 6 plus bracket 7 times 8 bracket. That should do the right thing, and we run the thing again, and we should get a more complicated. Yep. That's it's only going to a certain depth. So at this point here, the console.log is going, yeah, that's enough JSON for me for today. I'm not digging into this thing any deeper. So we're bailing out when we get to about here somewhere. But that's all right. We can work with that. Now, the thing that I was interested in doing yesterday is I did a bit of research overnight about TypeScript, and one of the things that I sort of discovered. Let's go and have a look at the TypeScript language documentation. TypeScript in 5 minutes, basic types, that's fine. What I discovered is, which actually kind of makes sense when you think about it, is that TypeScript, at runtime, the types are gone. TypeScript is a compiler or a transpiler that turns language with types into a language without types, and then the language without types is the thing that actually runs. So if you want TypeScript check type at runtime, which is the thing where you're sort of playing around with and looking at being able to do, it doesn't exist. There is no way of doing it because types are stripped away at compile time and do not exist, so you can't check them. So what we need to do is, the way we got this working yesterday was to use a discriminator. So if you have a look at this syntax.rockstar node thing, which was, by the way, it's called a Rockstar node. When it was just called a node, that started clashing with node, which is a native type in all kinds of JavaScript-y things. Bizarrely, it's a native type in client-side JavaScript that represents an HTML DOM element node, which has nothing to do with Node.js. So now you know. So we wanted to look at, if I have a look at my syntax.js or syntax.ts, this thing here, kind is a string. Now what I want to do first is, can I replace that with some kind of enum? Can I replace kind with an enum there so that it will do, I'm not relying on magic strings anymore. So let's have a look at TypeScript enums. And that looks like, yep, enums are one of the few features. Yeah. Hey, Cinciat, how you doing? Yeah. So JavaScript has no type, so anything is talking about Kotlin here and saying, add some meta information to the class so it can do type checking at runtime. And what I want to do is see, I'm going to have to add that because TypeScript doesn't do that automatically the way Kotlin does. Kotlin's very cool, by the way. But yeah, TypeScript is what we're playing with today. So if we wanted, we could leave off the initializers entirely. So that gives us an enum direction. Enum member must have an initializer. So I'm going to drop in a thing here. What I want to do is I want to say here, okay, so enum node kind, and I'm going to say in here I've got addition, I've got multiplication, and I've got number. Those are the kinds of node that I've got. Then I'm going to say this is a node kind, and then here I'm going to say, so that's already complaining because the language engine in VS Code. Hello Gareth, how you doing? Welcome. The language engine in VS Code here is going, hang on, you said kind had to be an enum here. Type string is not assignable to type node kind. So that thing there needs to be a node kind dot addition. Yep. And this thing here, kind needs to be a node kind dot multiplication. And this thing here, kind equals node kind dot Rockstar node. Yeah, you can. It probably supports that. I'll try that in a second. Hang on. So instead of making Rockstar node an interface there, yeah, absolutely, Gareth, go for it. Yeah, we were looking at this yesterday, and so we should now be able to. Yeah, that looks kind of nice. I like that. So instead of Rockstar node being an interface here, I can drop in so type Rockstar node equals one of those, or one of those, or one of those. Is that do we need that at the beginning, or is that a typo? Because that little or at the beginning of the discriminator there looks like it maybe doesn't want to. I don't know. It's me. I've been using this language feature for 90 seconds, and I'm like, yeah, that doesn't look right. I'm going to edit it and make it different. So now we've got that. That should be fine. Now implements Rockstar node in all these cases can come out. It's optional. F# might be in TypeScript too. Let's have a look and see, because if this works, then clearly it was optional. And I can see, like, you know, it is the kind of thing it would be very easy to make optional, and making it optional would make it very easy to build code generators, because you don't have to worry about whether an element is the first thing in a list or the last thing in a list. And, you know, if syntax like this is valid, okay, that's not valid. But that one, all right, let's see what we got. So we got a Rockstar node, we got the kinds, and now in our interpreter, which I'm going to rename here, to be interpreter.ts. So the harness.js I can delete, that can go. Now this thing here is being a little bit, I need to export the type there, don't I? So export that. Now node.kind, okay, so this is about to get a little bit cleaner, because now I can say case node kind dot, I need to export the enum, case node kind dot addition, multiplication, yep, that's fine. Case node kind dot addition and node kind dot number. This is complaining at the moment, and I'm not sure why. Cannot find name node kind. That's picking up syntax. There is no syntax dot. Let me delete that. So move that to the recycle bin. All right. I have a feeling something here is being a little bit confused by this sort of fairly complicated nesting structure that we got going on. But let's try it. So what do I need to do to get this thing to build cleanly is I need peg.js on parser.peg. Then I need tsc on syntax.ts. Actually, I should have done that first. Then I need that, and then I need that, and we'll see what that gives us. That should blow up because harness.ts doesn't exist anymore. Cannot find harness. Yeah, that's fine. That should now be interpreter.ts, and node is going to run on interpreter.js and see what happens. And that's interesting. Node kind is not defined. So import that from syntax, syntax.ts export enum node kind. Why has that not? So the node kind is exported there, right? So it has to be syntax, doesn't it? Thank you. Yes. Syntax.nodekind.that and syntax.nodekind.that and syntax.nodekind.not.that. If I get rid of that, what happens? Nothing. Right. So let's try plugging that through. There we go. Cool. All right. I like that. Git add dot git commit -m. Working with enum discriminator instead of string. Yep. Okay, so what I want to do now is look at how we bolt the whole thing together into... Okay, so first of all, optimization. I don't like this. This is very, very... the big old... having to explicitly typecast everything in here. So the way the structure of the interpreter that we're going to write here is I'm going to drop in a function here called multiply, and I may even... we're going to try one thing, then we're going to try another thing. So first thing that I want to try is and this thing, multiply, takes a node which has to be a syntax.multiplication node. And this thing is going to return evaluate. Now at this point we don't need to cast the node, because the node should already be something with a left-hand side and a right-hand side, because it should be a multiplication node. I think it's hacky as node.kind is an implicit requirement for all members of Rockstar node. Yeah. That's true, actually, because we could, if we go over here, so we got node kind Rockstar, so we could, okay, okay, here's the problem. Cinciat is absolutely correct. We could do export class, let's do a function node, and I could completely forget to put kind on there. But then up here, I can say that can be a function node. And then when I get back over into my interpreter, that thing's going to say, boom, does not exist. So although the TypeScript compiler is still picking this up at compile time, base class or discriminated union, that's the question, or is it an interface implementation? And I think it is probably an interface implementation that we want here, because all of these types have to implement kind. I mean, either of them could be made to work. Either approach is implementable. There's nothing impossible about either of them. What would be... yeah, no, we can't get down to the really, really nice level of just being able to switch on the type of the instance between the different things. So, yeah, if we didn't need the discriminator, then we would just be able to say we could forget about that, we could forget about that, we could forget about that, and over here we could write the... that could just be switch type of node, and that would allow us to do pattern matching based on the type rather than having to plug in the discriminator. But because the type information is getting erased at runtime, we need the discriminator, and because the discriminator is mandatory, we probably want the type system to enforce it and insist that it exists on every one of these things. And whatever we do, it's gonna... So the little voice in the back of my brain is going, what else could you do that wouldn't involve transpiling this thing down to JavaScript? And it's gone, do it in Blazor and ship it in WebAssembly. And I'm going, no. We're going to do TypeScript for this one. That's what we're going to do here. So I'm going to... I like the discriminated union thing, and we're probably going to find ways of using that later. Because, for example... there's a whole bunch of nodes in So I'll show you an interesting example. So we got function node, that we don't need, that we don't need. What was the interface, export interface, Rockstar node. Do it in Lua and ship it in WebAssembly. There's only 2 slight problems with that. I don't know Lua and I've never done WebAssembly. But hey, yesterday I'd never done TypeScript, so export Rockstar node, and this thing has a kind which is a node kind, doesn't it? And that's mandatory, and that one is definitely in there. That one's definitely in there. I have dabbled with Dart, actually. I did a bunch of stuff with Flutter at the start of this year, just out of curiosity. Very, very nice dev story. You know, very, very nice kind of hot reloading and all this kind of stuff. That was quite entertaining. So, but now, for example, we can probably do binary node equals addition node or multiplication node. And you know, I could put in, but then let's do export interface binary node. What's this? Is it implements the keyword? So that implements binary node. Yeah, that should be fine. So multiplication node, that's a binary node, that's all right, that's a number node, that's a number node. Export interface binary node implement. Can I do this? Is this allowed? Is it going to let me do this thing? Let's have a look. Interfaces cannot have implements clauses. TypeScript inherit interface from interface. Let's see what we get out the other side of this. Can inherit one interface into another. Interface mammal extends. Okay, just looks like extends is the syntax we need. Yeah. Okay, that looks nice. So binary node extends Rockstar node. So this thing needs to have a left-hand side, which is a Rockstar node, and it needs to have a right-hand side, which is a Rockstar node. And so now addition implements binary, kind, left-hand, right-hand. Multiplication, binary, kind, left-hand side, right-hand side. Yep, that's all fine. Does TypeScript support constructor inheritance? Class inheritance constructor, that, no, class that. So what I'm curious about is, can I move this thing up? And can I put binary, hang on, what if binary node is a class? Binary node implements Rockstar node, defines the left-hand side, defines the right-hand side. That's fine. Now, this now extends that, which means almost all of this can come out because all we need in there is that. And that extends that, which means we don't need any of that. We've just literally got that one and that one. Number node is still required. Binary comes out. That's our thingy. What was it called? Union thing. Discriminated union type. Export class binary node implements. What is that complaining about? Property kind is missing. Can we do... yeah, can we do abstracts? Right, Google time. Abstract property in TypeScript. Right. That appears to be not complaining in the Visual Studio. Okay, so let's have a look at our, that's not our code, we don't want to look at that. So our parser says return new syntax.addition node. So that constructor syntax, if this works, the constructor syntax will be inherited from the fact that a addition node is a binary node which has a constructor on it. Well, let's run that and see what happens. Any second now, I'm going to be building a... So actually, the command, I'll bake this into a packaged JSON script in a second. So we've got tsc syntax.js, syntax.ts. If that works, then peg.js, parser.peg. If that works, then tsc interpreter.ts. And if that works, node interpreter.js is the things we need to run in that order to run our whole project from start to finish. And that works, and it yields the value 88, which is quite exciting, because that's a good number. Not only is it the correct answer, it's also the number of miles per hour. The DeLorean needs to go back in time. Can TypeScript do self-references in classes? I make kind of reference to the containing class. By which you mean what? Could we do, like, abstract kind could be a Rockstar node? So the thing, I think the problem with that is that JavaScript classes don't exist. They do exist, but they don't exist. If we go over, let me do some really quick and dirty JavaScript here. If we spin up a browser and we go into a console window, and let's grab that, and class person this dot name equals me, unexpected syntax token dot this dot name equal that should work. Okay, so we got a person constructor. So now if we say new person Bob, that's a person with the name of Bob. Type of, so var Bob equals new person. Let me whack the font size on that up a bit. That's a little tiny. There we go. So we've defined class person, this dot name. They got a constructor, so we can say var Bob equals new person Bob. Okay. Bob.name is Bob, type of Bob, object. Yeah? Bob.prototype. Maybe we could do Bob.prototype. What I want to get to is whether the class has identity. I don't know if it does. So we can get the constructor function. It's all a little bit maybe. So you're thinking, is there any way from a property on the object we can get it to tell us the name of the class that was instantiated? Person.prototype.constructor is... does this give us anything useful? Person.prototype.constructor.name. This is filth, but we're going to try it anyway. So we are going to have a... so Rockstar node, binary node, there's that. That's the interface. Export abstract class Rockstar node. Yeah, so we've got class addition node kind equals Oh, I see what you mean. What would the type of that be, though? You thinking we could do something like this? And that's going to say no because it's a type of addition node is not assignable to type. Is there any notion of a type of or a type or something in TypeScript? TypeScript, name of type. Type guards, type compatibility, type inference. Any. Cannot find name any. What is any in TypeScript? All types in TypeScript are types of a subtypes of the any type. That's the any type in TypeScript. TypeScript, any versus object. Lowercase. Let's try that. All right. Okay. So that can come out now. That's defined up there. That could just be called type. You know that thing where you're hacking on some code and you're like, if this works, I'm going to have such a job figuring out why it works. So binary node, property type is missing in binary node, but required in Rockstar. So this needs to be an abstract type, which is any. So that's all right. There's the left-hand side. There's the right-hand side. Kind equals number node. Okay. What do you think this is going to choke on? Let's have a look and see. Is that going to work? Yeah, okay. Rockstar node is missing the properties. Okay, that's interesting. That's not as bad as I thought it was going to be. So, you called type kind and number node. I did, thank you. That's there. Why is that complaining? Constructors for derived types must contain a super call. Super nothing. Yeah, that's fine. All right. Can we do this? Does this work in TypeScript? No. Speech synthesis. Do you love that thing where you type something like super and it just goes, yeah, you obviously meant a speech synthesis utterance because that's the closest thing I found. Right, let's try that. Boom. Run it. See what we get. Switch node.kind is not working, so let's go into our interpreter. Switch node.type. Case syntax.multiplication node. If this works, I'm gonna be surprised, pleasantly surprised. Oh, that's nice. Oh, that's nice. Oh, that's lovely. I hate to, what does the JavaScript look like? Wow. That's pretty much, yeah. Wow. That's all right. That works. Beautiful. Right. So what I want to do now is So first thing I want to do is I want to take some of this inline type coercion we got out of here, and I got, so multiply is going to take a multiplication node. So can I say, instead of that, just say return multiply node? Is that going to work? And if not, why not? And it's not going to work because Rockstar node is not assignable to multiplication node, but it is because we can do that to coerce that. So there's our multiply function. This is going to be our add function. That is going to be a syntax dot. So that can just be a binary node, and that can be a binary node, because we know that in both cases it's just a left and a right we got going on there. So we got binary node is there. We got binary node there. So at this point that can just be add syntax.binary node node, drop that out. That's nice. That's interesting. That's more like it. Math is hard. Let's go shopping. So there we go. All right. We've got a syntax tree. We've got the correct answer coming at the other end. That is really quite nice. The last thing that I'm wondering here is, can I say the last thing I'm wondering, this is probably like day one of like 20 or 30 days of streaming to get this thing kicked into the shape that I want it to be in and out there on the web where people can play with it. But what I'm wondering is, can I do, instead of switching on node.type, return engine node.type. So the basic math syntax is, this is all about tooling. That's what we're doing at the moment, is once I've got this to a point where I understand the capabilities of TypeScript, the language, and I've got something baked in that can take the various TS files and combine them and run them, at that point it's basically picking up language features, and there isn't working implementation for most of them. You know, I can probably 90% of the Rockstar interpreter I could implement from memory once I understand the syntax, the way that it needs to be done. So evaluate and return engine node.type node. So yeah, math, Rockstar, profit, done. It's my business plan for 2020. So I want to see what happens if I do that. And now down here, I can say, so what do we got? Let engine equal, so this is going to be, draw a circle, draw the rest of the owl. Yeah, well, you've drawn a lot of owls. This is just working out a better way of drawing the circle, and we're just going to fill the owl in from memory. So engine syntax.multiplication node. Oh! It was going so well. But look at that. We can't use types as indexes. I guess there had to be a limit to how badly we could abuse the TypeScript engine in the course of doing what it is that we wanted it to do here. So I'm not going to be able to do that. But that's all right. I can live with a switch statement in here. So right. Okay, so what I want to do now is, interestingly, this project has a package lock JSON, but it doesn't have a package JSON. I wonder why that might be. So I don't think I've ever had to bootstrap a package JSON. Package JSON build steps. Ooh. So Cinciat has just suggested you could define an evaluate method on Rockstar node and implement the logic in each of those classes. So that's hang on. I'm gonna take a brief diversion. I just want to get the so we need a, what do we do? An npm in here. Let's run that. There we go. Package name, yeah, TypeScript hex will do. Version 1.0, why not? Description is blank. That's interpreter.js. Test command is fine. Git repository, don't care. Keywords, author, yes. Is this okay? Yeah, looks fine. Boom, right. Open that up. Package.json, scripts, build, so, and we want to say build is gonna be, what was the syntax we had on the command line thing there? It was something like that whole lot there. Let me grab that and Shift Control C should copy that, and over here, and there's that lot, and that comes off, run. Can you define dependencies? Package.json script dependencies. Scripts, yeah, script start, script, that's fine. Say hello, script start that, say hello that, yeah, that's fine. The way to call an npm script within... Okay, cool, that's fine. So, I want a run command in here, which is npm run build and node interpreter.js. So that's baked in, that's fine. So now I should just be able to come over here and say npm run build. Yep. There we go. npm, what was it called? npm run. No, that needs to be start. Yeah, okay, so that's working. So, Cinciat's suggestion, which I really, really like, enough to try it and see if I really, really, really like it, is can we define a... This is about to get weird, I think. What is evaluate going to return? It's going to return any. Is that how you define methods on abstract? Evaluate returns any. So that one's in there. This isn't procrastinating. This is continuous learning. Thanks for stopping by. Maybe see you on another stream at some point in the future. So we've got an evaluate on that, and now a addition node extends binary node type equals that. So we need now to say on here, evaluate. So this needs to say return LHS.evaluate multiplied by this .RHS.evaluate. So that's going to be plus because it's that one. I wish we could do that syntax in JavaScript, but we can't. That's a .NET thing. So we've got, yeah, you too, Vamsa, have a nice evening. So we got type equals multiplication node, and evaluate is going to return evaluate multiplied by evaluate, which is kind of fun. And then finally evaluate on here, evaluate is going to return value, because, you know, okay. So now our entire thing here vanishes, just like that, disappears with a puff of logic. Let AST equals that, console.log AST, and console.log AST.evaluate. Look at that. Now that's nice. What I'm doing is I'm thinking ahead about probably 10 or 15 steps right now. And I'm thinking, when it gets to things like flow control, is this gonna become a problem? Is implementing something like a break statement going to actually, no, it shouldn't. It shouldn't, because the program is gonna become a list of statements, and what we need to do, I think, is to bake in here some very, yeah, let's go with a very simple, like a loop implementation and find out. Except we haven't got anything we can loop over, really. So, what's the simplest thing? We need to probably capture some kind of environment, and we need some kind of flow control. Yeah. Right, hang on a sec. Let me grab this lot. Get add dot, get commit minus m, move the evaluate method onto the node itself. I can't git push. I don't have a remote repo for this stuff yet. So let's write a very, very simple program here. What do we need to validate this? We need assignment so we can capture things in an environment, and we need some notion of flow control. So I'm thinking something like let x equals 5, and or even let x equals 0. That'll give us the environment capture. Let x equals 0, and then loop if x is greater than 5, break x plus plus. Right. It's trying to simplify the grammar here to make the parser definition we need to, or the grammar definition we need to write for this thing, be the simplest thing possible. And we're gonna need a yeah. So the thing I think it's gonna yield to, the thing that I think is going to make this work, is that at the moment we've just got ast.evaluate, right? But actually our program is gonna be a block, and a block is gonna be a list of expressions, and each one of those expressions is gonna be some kind of result. We need to return a result from evaluate, which has both a value and some kind of continuation, I think. So we've got our, let's plug in a grammar that works with this thing. So what do we need to do to make this thing work? To make this thing work, we need assignment, which is a let. We need a loop statement. Yeah, it will be expressions all the way down. So if can be an expression without needing an else. You can just have if x is greater than 5, it returns true, otherwise it returns false. So this entire statement here can have a return, so it's an expression, as well as being so anyway, we need a actually x, that can come out, that can be x equals x plus 1. So we need assignment, we need a loop, we need expression, we need a conditional with a consequent alternate maybe, don't know, we'll look at that in a second, and we need yeah, okay, so grammar we're going to need to make this thing work is, so we've got our syntax, we've got a, you mean we need a break in our language syntax, or we need a break on the stream? Because I'm going to do another half hour on the stream, and then I'm going to knock it on the head and come back to it tomorrow, but we need a break in our language definition. So we got that lot, we got that lot. So what do we have here? We've got an assignment, so a start here. So now we need a block, and a block is gonna be a block is gonna be a list of lines, basically. So we've got a program equals either a line followed by an end of line followed by a program, and if that happens, we want to return. Now this is where it gets slightly interesting, because program is now going to be a array of things. Hey Sahil, how you doing? Return line dot concat program. So if we get line EOL, so first of all, let's have a rule here right at the end that says, so EOL equals a optional /r followed by a literal /n, because yay, Microsoft Windows. That's fine, consume that, that's fine. So a program is a line that has that, or it is just a line, in which case return the line. So that should give us the syntax we need for this thing. And then I'm just gonna say now that a line can be, no, it's, the plan at the moment is to kind of come up with the guts of, so that the step that I'm at is I've wanted for a while to rebuild the web-based interpreter for Rockstar and TypeScript. Yesterday was like, how does TypeScript work? Let's kick around the shape of the thing, see how it works. So I'm up to like, what is it now? 2.5, maybe 3 hours total TypeScript experience. The thing now is to identify the, so arithmetic is easy, like that's solved. I now have no hesitation at all that that's just a question of plugging in the right syntax and the special cases and stuff. What I want to do now is just figure out here in this little throwaway prototype how to do flow control using the notion of a strongly typed abstract syntax tree, which has evaluation behavior on the nodes in the AST instead of being in an evaluator somewhere. And if that works, then we put all this to one side and go, right, that's the reference for how we do the TypeScripty things. This thing over here is the existing JavaScript interpreter, which is a reference for how to do the languagey things and the Rockstar-y things, and then just start building up another one by pulling in test cases and hacking it till they pass. So So this is going to be a sort of a reference implementation, probably as much for the tooling and the syntax, which will then be put to one side. Hey, you're not interrupting. If I don't want to be interrupted, I wouldn't be streaming live on the internet, right? So we've got a thing in here. This says, okay, so a line is additive, and an additive is that, and a multiplicative is that, and primary is that, and that's all fine. And that's end of line. So this thing should now allow us to parse a. So I'm going to take out those because those are temporarily not necessary. That program is going to be, program 1 is going to be that lot. But let program 2 equals, what I want to see right now. So, oh yeah, the monad song. That's fun. The monad song is one that doesn't really work for live streaming because you need to be able to hear the audience shouting out at key moments in the lyric there. So let's say 1 plus 2, 3 plus 4, 5 plus 6, times 7 plus 8 plus 9. So this should be parsable. And what this should give me back is an array of, let AST equals parser.parse program 2. No, having Don on bass has been a lot of fun. We used to do a bunch of events together at Skills Matter when he was doing the F# exchange. And that whole, the music thing has just really kind of grown organically out of people going, oh, you play guitar, all right, you come and hang with us for a little while. npm run start, wasn't it? That was the syntax we built in. There we go. So let's see what this thing does. So we should get an array with an abstract syntax tree at each element of the array. Boom. No, we don't. Why not? Expected bang or integer, but a new line found. All right, that's. Oh, yeah, of course. Program can't start with an empty line because it doesn't know how to do that, because we have not defined any support for consuming empty lines of program. Let's run that again. Yeah, the Black Books reference was let's see who's paying attention to this thing. So, boom, reference error. Line is not defined. Line is not defined because I've not captured it anywhere. Program equals that, or program, so L line, or actually let's make that head and tail because that's nice. Item line, actually if that happens we want to return an array because we want to give back that thing on its own, and head line return, yeah, that should work. Head tail, so return head.concat tail, one of my favorite little JavaScript invocations. Item line return item. Okay, let's run through that lot again, see what we get out the other side of it. I was on Netflix, Amazon Prime the other day talking about Black Books. There's a whole series too that I realized I kind of missed. It's like I thought I'd seen the whole thing because I remember watching season 1 and season 3 very well. But there's whole episodes in season 2. It's like, I don't think I've ever seen this before. That's blowing up. That's blowing up because expected star bang slash r question mark slash n or end of input but slash n found. Interesting. Interesting. Series 4? No, never. Sure they didn't make a series 4 of Black Books. Number series 3, yeah. And that's from Wikipedia, so it must be true. Anyway, I digress. Empty line at the end, maybe that should be, actually, if I do that, is item, head, line, tail. Yeah, probably an empty line at the end of the program. Let's try that. No, I got a slash r in my grammar here, Tanal, so the slash r there should not be a problem. That has been accounted for. found /n. Interesting. Why is that not working? Why? Offset 3, line 1, column 4. It can't cope with... what can't it cope with? Can't cope with that. Can't cope with the new line at the end of the first thing. Is it a... Yeah, it's kind of a regex. It's a expression grammar syntax thing. Let me dig out the Satriani interpreter and see how that does it, because I know that works. github.com/rockstarlang/rockstar. Satriani rockstar.peg, and that one. Ooh, where's my EOL definition in here? Not quite the right syntax. It's that. It's literal string with a qualifier after it, followed by a different literal string. Not 100% confident that'll work, but I am confident it's gonna move the error message to somewhere different. Okay, cool, brilliant, that worked. So what it's given us now is we can parse programs that have lines. Yeah, complex numbers are like project plans. They have a part that's real, they have a part that's imaginary, and they are no use at all in figuring out what is going to happen next. Addition node, left, right, type, addition node. So we've now got an array of nodes coming back. So now our evaluator program becomes a so basically it becomes ast.for each node goes to node.evaluate. So that's a very, very simple interpreter, which is going to do nothing because our program at the moment has no input-output capability, right? So I'm just thinking, I've got another 20 minutes today. I'm thinking, what's a good point to get to that we can end today's stream with something useful and working, and then come back and build on the next bit tomorrow. And I think probably a nice way of doing it is to plug in a very, very basic what do we need? We need assignment support. So let's build in assignment support. So our program now, so okay, at this point a line is going to be an assign, or it is going to be an output. And assign is going to be a let. So we need some kind of white spacey thing in here. So underscore equals, and this can be a space or a tab, and it's got to be at least one. Yeah, okay. 0 or more, 1 or more, 0 or more, 1 or more. I'll see if that breaks later. So we've got a thing that says let, and then a space, and then v, which will be some kind of variable, and then some kind of space. Yeah, we could define a block in the syntax type. This is where the bit about flow control, I haven't figured out yet how that's going to work, because we may need something at the very top level that knows that the last thing that you executed was a return statement or a block statement, and so it can bail out and return control to the main loop. But we'll get to that in a bit. So variable, and then equals, and then a expression. And then an expression in this language is additive, and output equals, so we're going to get a little bit rockstar-y here, say e expression. Okay, and if we get one of those, we are going to return a new output node, which is a syntax.output node, which has an expression of So node is going to be an expression. Node, that will be fine. So that'll do that. That'll do that. So in my syntax.ts, I need to define an output node. So there is the syntax TypeScript. Export class output node extends Rockstar node. Type equals output node because we need that. Actually, we don't need that. We were going to just get everything to evaluate themselves, weren't we? To make the whole thing even leaner. So there's that, there's that, there's that. Which means that's not necessary, which means that not necessary. All we need is the evaluate method in here. So output node extends Rockstar node. That's fine. So I need a constructor on this, which takes a node, which is a Rockstar node. And this just calls super and says this dot node equals node. That's fine. It looked nice, but it's relying on types to get you to allow some external thing to look at I liked it. It's a beautiful piece of code. I just think we can solve the problem with even less lines, even fewer lines. And that's nice, because the smaller something like the interpreter is, then the easier it is. So I've got a node on here, which is a Rockstar node. Okay, so there's that. There's all that lot. And evaluate on an output node. So at this point now, I'm going to do a slightly dirty hack here, because I'm going to say return console.log of node.evaluate. Because that's effectively what we're doing. So we've got a let result equal that and return console.log of result. Everything has to return something because everything is going to be an expression. It is up to you whether you want to do anything with the returned result of a console.log. You probably shouldn't. So what I should be able to do now is in my grammar, let's take out that output expression. That assign is temporarily commented out. The syntax highlighting for the peg here is a little unusual. I think it's choking on my color scheme. So now our program over here should be, what was it, say was my output expression? Yeah, so say 1 plus 2, say C plus 4, say that should be valid. Let's run that. Boom, that works. That's fine. That's gonna explode, I think. No, it's not. It works. Cool. So we've got output nodes containing addition nodes, and they are generating output. 1 plus 2, 3 plus 4. Yep. Okay, so that works. Now we need to add something that is a little bit gnarly. Do we need... It seems very slow, but it's rebuilding the whole thing from scratch every time. If I just do npm run interpreter.js. Ooh, that's interesting. Node interpreter.js. Boom. That's how quick it actually is when it's not compiling TypeScript and then grammar and then TypeScript and then grammar and then running the result at the end of the thing. When you just run the thing, it's nice and quick. So that's our interpreter. That's all right. So we've got it putting out the block, each node.evaluate. Now what I need is a way of saying, actually I'll tell you the easiest way to do flow control here is to have a return statement. That's the easiest thing we can do that will require support for not running the next thing in the block. So if I come over here and I say assignment is difficult because to do assignment we need to create an environment, which means we need to plug in a bit of infrastructure around the outside, which is probably a step further than I want to go today. So output or return and return equals return and then node expression, and this will return a new return syntax dot return node. And this is where it all starts to get a little bit meta, because in our syntax.ts now, I'm basically gonna grab that whole lot there, and I'm gonna say public export class return node extends Rockstar node. So there's that. Now at this point, the evaluate method needs to do something different, because the evaluate method needs a way of not just giving you back a value, but of telling the interpreter what it should do once that value has been returned. And so, very simply, what I think we want to do here is to have some kind of export. Basically, we're returning a tuple. Returning a tuple where this is the result of the expression, and this is what you need to do next. This is the next thing that needs to happen when the program is executing. And so I want to return a from one of these. So that's a result. We're going to console.log it, but then we are going to give back. Now at this point, I probably want a new something in the type system. Export class. I have no idea what to call this thing yet, because I don't know what it's going to be used for. So I'm just going to call it a result. And inside result, I am going to have a value, which is going to be any. Actually, well, it's not quite action because it's got 2 bits. Thing will do until I think of a better name for it. It's a horrible name, but it'll do till I think of a better one. So this thing, and then I want a constructor on here which says action of any and result of any, and this is just gonna say, and at this point we're basically doing, you know, old school JavaScript type stuff. Actually, you know what? To validate the approach, we don't even need that. I can just return action is return and result is result. That's fine. I can return that out of there and up here. So that is just going to do that. That is going to do a, now the, yeah. It all sort of devolves into words for do and thing. So return result is result, because I'm assuming that console.log here is not doing anything. This one here, we just want to evaluate return, and that is just going to have a result, which is this dot value. So that's fine. Evaluate, that's going to return a result, this dot value times that, that's all right. And up here, I want to return a result, which is this left-hand side times that left-hand side, except evaluate now gives back that. So yeah, at this point, some kind of type checking would be good, because I want to make sure that all the things that evaluate return evaluatable things that can evaluate properly. This dot evaluate dot result, that's fine. That returns a value. That returns a value. That's okay. And so now, in theory, if I come in over here and I say, so this is where we build the engine. This is where we build the thing that's going to go through the block of expressions. So ast.forEach. Now at this point, I want to say node goes to this function, so we're going to say var result equals node.evaluate. That'll run the code. And then we want to say switch node.result. And if node.result is return, at that point I want to, return, which I can't currently do because I'm not inside a function here, but that doesn't matter because that will, a return in here is kind of, really, it's more, it's an exit. It's a break out of the program. It's a quit statement. Let's make it a quit statement. So return node is now called a quit node. That's a quit node. Constructor is fine. Node is fine. That's one of those. Result equals this.node.evaluate. That's not going to do anything. And that's just going to return an action of quit with no result. That'll be null. So that's that. That's output node. But in our grammar now, we want to say return equals quit. So that's called quit. That's called quit. That's called quit. The reason I've dumped return here is that it doesn't. We're not really returning anything. That can be a syntax.quit node from quit. Okay, that's fine. What's the Node.js for get the hell out of this program and don't run anymore? That should work. Case quit, that's fine. Yep, okay. So if I run this now, it should print out 1, 2, 3 values to the screen. But then if I drop a quit in there somewhere, I need to run the whole thing again, don't I? npm run start, boom. Build and compile and do all the things, and there's all that kind of stuff. Node.evaluate is not a function. No, it's not. That's very, very good. That will be node.action, not node.result. Run start on that. That should hack around. Okay, so that's pretty cool. Look, it's given us result 3, result 7, result 264. The reason it's doing that is that our console.log here is that needs to be result.result, which should probably be called result.value or some such thing. So there we go. We got 3, 7, 264. And what I need to do now is just put a line in there that says quit. Let me check the syntax for that is correct. Yeah, so quit is just a thing on its own, and it doesn't take anything after it. So rerun the whole lot, and this should now just print the value 3 and then bail out. And that's that. Done. Boom. And it's not, and why not? Because node is not defined, because a quit node has no value. It doesn't have anything. It's just that. That's all it is. And if we evaluate it, it gives back a thing that says what you do next is you stop. That's it. You're finished. And that's not done what I expected that to do. Result equals node.evaluate, return, action, quit, result, null, evaluate that, that's fine. Console.log, it didn't stop exactly. Let's console.log result and see what we get out the other side of that. It's possible that I just have not, action, quit, result is null. Switch node.action. It's possible exit here does not do what I think exit does in Node.js. So let me just see, Node.js exit application. How to exit from a Node.js process.exit. That's interesting. Result contains result 3. Action quit, result null. So that should be... we're on the right track. At this point, it's just a question of semantics. Hello, Niall. How are you? I'm switching on the wrong thing. I'm switching on node, not result. That's what I'm doing wrong. So at this point, result.result is the number. Result.action is the next thing to do. Now that is exactly what we want, because exit code 1 says this didn't work. If we change it to exit code 0 and run the whole thing all over from the beginning again. There we go. So last little bit. Last thing for today, then I'm going to knock it on the head. Let me just push this, or stick the slot in the Git repo in case I need it back in a minute. Git add.git commit -m flow control is kind of working. So what I just want to do is jump back over into my interpreter. Did I? Syntax.ts, that's what I want. And I want this evaluate method to return something. So I'm going to create a export class. What do you call the thing that you get? I'm just going to call it a result. And then a result is going to have a value is anything. And we can put an enum on here, which is exported, which is export enum flow, which has a value of exit, and a action, which is gonna actually that can be 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 that. Let's have this thing return. Yeah. And an action is an action, so that's fine. Export cross result, but evaluate now gives back a result. Has to, in every case. So evaluate here, property evaluate is not assignable to, yeah, that needs to give back one of those. And this thing now needs to give back a new result. Result needs a constructor. So constructor... value any action action. Can we have multiple constructors on TypeScript things? Can we do this? Is that allowed? No, multiple. I do like it when the error message literally answers your question. Like multiple constructor implementations are not. You see that there? That's a good error message. That's like, no, the thing you are trying to do is impossible. So maybe default values. Can we do that? TypeScript default values. Optional and default. First name string, last name string, first name string, last name. So we can have optional parameters. Which might give us what we want. First name, last name equals. Okay, so yeah, so we can do it. So action can just none. That's don't do anything special next time. Value action. So that can now be set to be action.none. And value can be any. So we got to give it some value. There's always got to be something, because every expression has to return something. So we got a constructor, and it's going to say this dot value equals value, this dot action equals action. That's nice. Okay, that's all fine. Evaluate returns a result. So evaluate return new result. So value is going to be that chunk of stuff there. So evaluate returns a result. Let value equals this dot left hand side dot evaluate dot, what did I call that thing? Value. Value, this right hand side evaluate dot value. Yep, that's fine. And I need to return a new result. Value should give us what we need on that one. That's the addition node. That can come out. Let's drop this in here. So that comes out. That needs multiplication now because that's how that thing works. Nice thing about this, just again thinking ahead a bunch of steps, is that these nodes now can be split out into separate classes, which will give me, because Rockstar has some really complicated stuff, like you can multiply strings in Rockstar, because why would you not want to multiply strings? If you say like 10 times foo, you get foo, 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 foo. And that means that there's actually some quite gnarly logic that's going to go in here when it's implemented for real. So that's going to implement a result, and that is literally just going to return a new result of this dot value, which is fine and nice. Our output node is going to return so it's going to console.log the thing, but then it's going to give back the value of the thing that we console.logged. So it's going to return that needs to take a result as a type parameter, and it's got to say return new result, except result is called value now. Oop. Yep, that's nice. Scrub that. And this one is going to return a new result. Action is null. And this is going to be action.return. And this isn't called quit node anymore. This is in fact called return node, as it was to begin with, because we are now going to have the ability to return an expression. So a constructor takes a node of Rockstar node, and this is gonna grab that lot and drop that in here. Actually, I can scrub that whole lot, replace that with that. Let value equals node.evaluate. Yes, that's fine. And then return a new result of value and action.return. Jump over into our grammar here, and we're gonna say that's not a quit anymore, it's a return statement. The keyword is return. It needs that. It needs node, which is an expression. And it is going to return a new syntax.return node, which is one of those. A line is an output statement or a return statement. That all looks pretty solid. So what we've got now is console, that's fine. Return node is fine. I maybe don't need these type annotations, because I think as long as I'm just returning a new result, it doesn't matter that they're missing. I think. I'm quite liking TypeScript. As you can tell, I have a wealth of experience with it at this point, but so far so good. Right, let me just compile this and see what I forgot. npm run start. Yep. Syntax.ts error. Where is syntax.ts? That is return new result on that. That's there. Now, we've just hit that beautiful paradigm shift you get when you're developing interpreters, which is where you suddenly go, that's a bug in my program, that in the language that I invented, I now have a bug in the thing that I invented. So I can now say return 0 here, and if I run that again, I should get a clean build and a clean exit, and it'll be green. Which is fine, and that's console.log in a whole bunch of slightly gnarly stuff. But if I return 2 now, this is going to give me a non-zero exit code. Yeah, there we go. Boom. Error number 2. So that line there is because the return value of our whatever language this is program is doing the wrong thing. Now I just need to fix one more little detail in here, which is our output node. Value is evaluate console.log value.result. So value.result is given back, evaluates given back result. So that should be value.value, which is the actual, the output that's coming out of that thing. That's a value, that's a value. This.value, this.value, console.log value.value. That should be result equals this and return, so log result.value. Because if you see here, we got all this result value, that, blah, 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 which is not the syntax that we want coming out of here. And so return node value equals this dot node dot evaluate dot value, because we need that should be that in every case. Yeah, cool. All right. So those console.logs are still leaking from here. So what we should get now is a very simple calculator program that can do arithmetic, and it has a return statement. Output node still has return result. Let's have a look at that. It does indeed. That should be value. That's why that's confusing. Yeah. I think. Yeah. You still have quit in your switch case. Go. Scrub that lot. That we can come back to later. That doesn't matter. That we don't want. Let's change that to be program equals. So there's our syntax. Yep, let that pass that. That's what. Why is that complaining? What does that want to do? That wants to. Oh, of course, this is TypeScript. Yes. Yeah. Yes, since that's a very, very good example of why having something called result and value is a bad idea when you don't know which one's the result and which one's the value. And sometimes the values are results and sometimes they're not. Interpreter.ts line 16 bracket expected. Yeah, that should be there. That should be there. That's fine. That should work. Okay. There we go. That, clear that. Run that. Yep. And finally, syntax to action return exit result.value. So we should now be able to run little programs in our number script language or whatever it is you want to call this. And that one is blowing up because error number 2 means it returns something bad. But if we put a return 0 in that, there we go. And if we move that return statement down, say 1, say 2, say 3 plus 4 plus 5, say 6. Return 0, say 7, 7, 7, 7, 7, 7, 7, 7. We should never get to that point in the program. There we go. I think that's enough TypeScripting for today. Thank you very much for tuning in, gang. That was cool. Actually, it was really, really interesting. There's some really, really great discussion and suggestions on the chat and stuff today. So thank you very much, everyone, for chipping in with that. I'm going to keep doing this. So basically, January this year, I got a bunch of stuff going on. I got a NDC London is happening at the end of January, and I'm doing a whole bunch of stuff for that. But I might, as some of that, get some of the folks who are attending. It's a virtual conference. Check it out, ndclondon.com. Buy tickets because it's full of brilliant people talking about amazing stuff to do with software and technology. And it'll be like the 6th NDC conference that we've run on the internet, and I helped put the program together for it, and it's going to be awesome. So yeah, check that out. A little bit of a plugging there for it. But yeah, so I'm going to try and do this most days, because it's actually really kind of nice having like a couple of hours where I just have to, it's a very, very focused way of working. It sounds weird, but having people kind of watching what you're doing, it stops you getting bored and going and browsing Twitter and Reddit and all that kind of stuff. So I think that, so far yesterday and today, actually really, really good progress in terms of understand and kicking around the shape of the thing. Next steps are going to be to basically lock in a project structure and start plugging in some tooling to do. So I'm going to be, I talked yesterday about the way the test structure on Rockstar works. I want to do some jest, like unit level testing, as well as the really high level integration testing, just because it makes it easier to see how things are behaving and make sure everything is hanging together properly. I used the old Satriani thing, used Mocha. It's all right. Jest is nicer. I've been working with Jest on some of my other JavaScript stuff. So yeah, I'm going to be doing this most days until we have a working interpreter. Then I'll probably have another break, and then I'll think of another daft project to do live streaming on the internet. Right, so folks, those of you who are on Twitch, we're going to see if anyone I know is online, so we can go and pay them raid them and pay them a visit on there. Let's go and talk to I Develop Things is online. Let's go and raid that. So Twitch folks, let's go raid in. YouTube folks, thank you very much for watching. I'll see you online for the next one. Thank you, friends. Take it easy.